Good day and welcome to today's class. Today's class is a continuation of our previous classes on perfect square. At the last class, we looked at making an imperfect square a perfect square. At the previous class, we looked at making quadratic expressions perfect squares, where we said to make non-perfect squares quadratic expressions to be perfect squares, first make the coefficient of the first term of the given quadratic expression a perfect square. Then square half of the coefficient of the second or third term in order to obtain the third term. And we said this is because the middle or second term of a perfect square is always plus or minus twice the square root of the product of the other two terms, that is the first and the second term. And at that last class, I gave you some examples, and I left the class with an exercise or an assignment where I asked you to find the constant that must be added to make each of the following quadratic expression a perfect square. And if that is done, then you factorize. Before we continue, kindly subscribe to this channel if you are yet to do that, while you are to use the comment section to interact with us, and you are advised to share this video, the link of this video, to your friends and family so that they can also benefit from this class. In today's class, we shall be solving the assignment I gave you at the previous class. Question 1 says a squared plus 3a. That we should find the solution. A squared plus 3a. Now what we have to do is to first of all look for that constant term that when added to this expression makes it a perfect square. Now this is a two-term expression. We need to make it a three-term expression. And what did we say is that third term that when added to this expression, it makes it a perfect square. I gave you two methods which you can use, but I will be using those two methods interchangeably so that you can perfect it. So in question 1, I'm going to use method 1, and in every even numbers, then I'll be making use of question 2, or as the spirit leads. So for question 1, that what must be added to this expression to make it a perfect square? We say let that constant term be k. And the method says you should first of all make sure that the first term is a perfect square, of which a squared is the perfect square. Subsequently, you find the square of half the coefficient of the second term, which is this. So the coefficient of the second term, which is 3a, is plus 3. So I'm going to look for half of 3 all squared. So half of 3 all squared is said to be that term that when you add, is said to be our k. Okay, so this is equal to 3 over 2, and k is equal to 3 over 2 squared, and 3 over 2 squared is equal to 9 over 4. So 9 over 4 is that term which when added to a squared plus 3a makes it a perfect square. And the question says we should therefore factorize. So we have a squared plus 3a plus 9 over 4 to factorize. So how do we factorize this? This can be written as a squared plus 2 into 3 over 2a plus 3 over 2 squared. How did I get this? Remember, at the last class, or in one of our classes, which is the first class, we said if a quadratic expression can be expressed in the form x squared plus 2xy plus y squared, it is said to be a perfect square. And this perfect square can be factorized into x plus y all squared. So all I did was to write this expression in this form. And once that is done, you can thereafter factorize it in this form, where x is said to be the first term and y is said to be the middle term. So when you compare, you agree with me that this can be written as a plus 3 over 2 all squared. So when you factorize, this is what you will get. Question 2. D squared plus 5d. I'm going to use method 2 in solving this. And we said, let that constant term be k. So we have it as d squared plus 5d plus k. And we said, if this is a perfect square, then it therefore means that this can be written as d plus a all squared. So this can be factorized to this. So what is k? The value of k is what we are looking for. So I'm going to simplify what I have on the right hand side. This becomes d squared plus 5d plus k to be equal to, you agree with me that this is going to give us d plus a into d plus a. That's what square means. Okay? This becomes d squared plus 5d plus k is equal to, simplify this, you have d squared plus ad plus ad plus a squared. And when you simplify this further, you have d squared plus 5d plus k to be equal to d squared plus 2ad plus a squared. Now, by comparing the equation we have on the right hand side with that on the left hand side, you agree with me that d squared is equal to d squared. We have 5d to be equal to 2ad. What is a? Divide both sides by 2d. And you have it that a is equal to 5 over 2. So if a is equal to 5 over 2, what will be k? K, which is the last term, is equal to what? A squared. And k is said to be equal to 5 over 2 squared, where k is equal to 25 over 4. So 25 over 4 is that term which, when added to d squared plus 5d, makes it a perfect square. So therefore, I have this to be d squared plus 5d plus 25 over 4. Now that we have gotten that term that makes it a perfect square, we can then factorize. This becomes d squared plus 2 into 5 over 2d plus 5 over 2 squared. Remember, we are to write it in the form of x squared plus 2xy plus y squared, so that this can be factorized to be d plus 5 over 2 all squared. So this is how you factorize an expression that is a perfect square. Question 3. We have n squared minus 4n. So I'll go back to method 1 and use method 1 in solving this. So this becomes, we said, let the first term be a perfect square, which is, then k, which will be the third term, is said to be equal to square of half of minus 4. So that's, you find you square half of the middle term, which is the second term, and half of minus 4 is said to be minus 2, and minus 2 squared is said to be equal to 4. So 4 is said to be that term which when added to this expression makes it a perfect square. So this becomes n squared minus 4n plus 4. So let's factorize. This becomes n squared minus 2 into 2n plus 2 squared. And this can be factorized to be n minus 2 all squared. Remember, I said if the second term is a negative, your factor is also going to be negative. So we have it at x squared minus 2xy plus y squared, which when factorized becomes x minus y all squared. Now you can compare this with your answers and know where you have missed it. Question 4, x squared plus 8x. So you are going to use method 2. So we said let the third term be k. This now becomes x squared plus 8x plus k to be equal to x plus a all squared, where a is a constant term. So if a is a constant term, we expand what we have on the right hand side. This becomes x squared plus 8x plus k to be equal to x plus a times x plus a. This becomes x squared plus 8x plus k to be equal to x squared plus ax plus ax plus a squared, which gives us x squared plus 8x plus k being equal to x squared plus 2ax plus a squared. And when you simplify this further, by comparing the coefficients, you have x squared to be equal to x squared, 8x to be equal to 2ax. Dividing both sides by 2x, you get your value for a, and our a gives us 4. For 8 divided by 2 is 4. So we have our k squared, k to be equal to a squared, which is equals to 4 squared, and 4 squared is equals to 16. So 16 is that term that when you add it to this expression, it makes it a perfect square. So let's factorize. So we have it to be x squared plus 8x plus 16. I hope that's what, okay, yes. So we can then factorize this by rewriting this as the expression x squared plus 2 into 4x plus 4 squared, so that this can be factorized as x plus the last term, which is 4 all squared. So that is what you will get. Question 5, u squared minus 7u. What is that last term? We say the last term is what? K, and k is defined as half of the coefficient of the second term all squared. This is our method 1, and this is equal to minus 7 over 2 all squared, and minus 7 over 2 is said to be 49 over 4. So 49 over 4 is that term which when added to this makes it a perfect square. So let's factorize. You have it as u squared minus 7u plus 49 over 4. So let's factorize. This becomes, when you simplify it, u squared minus 2 into 7 over 2u plus 7 over 2 squared. Now, how am I able to transform this to this? Since I'm to write it in the form of x squared minus 2xy plus y squared, I'll have to divide the coefficient of 7 by 2 and multiply it by 2, or I factorize out 2 from the coefficient. And when you factorize out 2 from this is what you get, which is 3 over 3.5, or 7 over 2. So that's how I'm able to get this. Then you write this as an index form of what you have in the middle term. So that's just the trick behind that. So this becomes bracket u minus 7 over 2 all squared. So this is how this can be factorized, since it is a perfect square. Question 6. X squared minus 2x. We are using method 2, so let that term be k. This becomes x squared minus 2x plus k to be equal to x plus a, which is squared. Okay, x minus a, because the last term, the middle term, is a negative. Once the middle term is a negative, your factor is going to be a negative. So this becomes a negative. So let's simplify. You can do that with me. This becomes x squared minus 2x plus k is equal to, I'm going to be skipping some steps, but when you simplify this gives you x squared minus 2ax plus a squared. I hope this does not confuse you. Okay, so this becomes, by comparing coefficients, you have x squared to be equal to minus x squared to be equal to x squared, and minus 2x to be equal to minus 2ax. But if you divide and make a the subject of the formula, by dividing both sides by minus 2x, you have it that x a is equal to 1. For minus 2x divided by minus 2x is said to be 1. Now what is k? K is said to be a squared, and 1 squared is said to be 1. So 1 is that term which, when added to this, makes it a perfect square. So we have it to be x squared minus 2x plus 1. Now factorizing this, you have to simplify it in that form. This becomes x squared minus 2 into bracket 1x plus 1 squared. For 1 squared is same thing as 1. So when you factorize this, it's going to give us x minus 1 all squared. Question 7. X squared plus x. In this next example, I'm going to be using all on method 1, and towards the end I'll use that of method 2. So method 1 says ensure that the coefficient of the first term is 1, is a perfect square. That's what we have done. And then find k, which is defined as half of the coefficient of the second term, and the coefficient of the second term is 1 because we have plus 1x. So k is the square of half the coefficient of the middle term. So k in this case is equals to half of 1 is half, which when squared gives you 1 over 4. So 1 over 4 is that term that must be added to this term to make it a perfect square, so that this expression now becomes x squared plus x plus 1 over 4. So let's factorize it. This becomes x squared plus 2 into half x plus 1 over 2 squared. This now becomes x plus half all squared. Question 8. u squared minus 10u. What is that term that when added to this makes it a perfect square? And I said let that term be what? K. And K is defined as half of minus 10 all squared, which gives us half of minus 10 is said to be minus 5. Minus 5 squared gives us 25. So K is 25. That means the equation becomes u squared minus 10u plus 25 makes it a perfect square. And this can be simplified to be u squared minus 2 into 5u plus 5 squared. And this can be factorized as u minus 5 all squared. Question 9. X squared minus half x. What should be added? Let the constant term be k. And we have k to be defined as half of the coefficient of the middle term all squared. So half of half is said to be 1/4, and 1/4 squared is said to be 1/16. Meaning 1/16 is that term that must be added to x squared minus half x to make it a perfect square. This becomes x squared minus half x plus 1/16, which this can be simplified further to be x squared minus 2 into 1/4x plus 1/4 all squared. Note that these two terms must be equal for it to be factorizable. So this becomes x minus 1/4 squared. So this is the factor. Question 10. Z squared minus 4/5z. So what is that term? We say let the term be k, and k is defined as half of minus 4/5 all squared, which is half of the second term all squared. So k is equal to half of this becomes half times minus 4/5 all squared. 2 into itself is 1. 2 into 4 is 2. So k is said to be 1 times minus 2 is minus 2/5 all squared, and this becomes 4/25. For minus 2 squared is said to be 4. So it therefore means that 4/25 is that term that must be added to this to make it a perfect square. So it therefore means that z squared minus 4/5z plus 4/25 will make it a perfect square. So let's simplify this further. We have it to be z squared minus 2 into, so when you factorize out 2 from minus 4/5, you'll be left with 2/5 z plus 2/5 all squared. This has been expressed as a perfect square, where this can be factorized to be bracket z minus 2/5 all squared. Question 11. We have m squared minus 6m, and we said let that term that should be added to make it a perfect square be said to be k, and k is defined as half the coefficient of the middle term or the second term all squared. So half of minus 6 is said to be minus 3, and minus 3 squared gives us 9. So 9 is that term that must be added to m squared minus 6m to make it a perfect square. So that becomes m squared minus 6m plus 9 is said to be a perfect square, and we can then factorize it by first of all simplifying it to be m squared minus 2 into bracket 3m plus 3 squared, and this can be factorized as m minus 3 all squared. Question 12. This will be the last example I'm going to solve using method 1. From question 13, we shall be looking at the method 2. So let that term be said to be k, of which k is defined as half of 2 over 3 all squared, and half of 2 over 3 is said to be 1 over 3, and 1 over 3 squared gives us 1 over 9. So 1 over 9 is that term that must be added to h squared plus 2 over 3, I beg your pardon, h, to make it a perfect square. This is 1 over 9. So factorizing this, we have to simplify it to be h squared plus 2 into 1 over 3h plus bracket 1 over 3 squared. And when this has been simplified, factorizing it becomes h plus 1 over 3 all squared. Question 13. In this question, we shall be applying the second method, and that says let the constant term be k. So if this is k, okay, let me use method 1 in solving this because of a special feature which I just saw, and that is the 14xy. Now the coefficient of the middle term is said to be 14y and not just 14, so take note of that. So this becomes k is said to be half of 14y all squared. So k is equals to half of 14 is 7y, and 7y squared gives us 49y squared. So 49y squared is that term that must be added to x squared plus 14xy to make it a perfect square. That becomes x squared plus 14xy plus 49y squared. So let's factorize this. We'll simplify it first to be x squared plus 2 into 7y x plus 7y squared. So when you factorize this, it becomes x plus 7y all squared. So this looks somehow different from the previous examples we have been encountering. So question 14, x squared plus 7x, let that constant term be said to be k, and if this is k, when added to this term, it must make it to be equal to x plus a all squared. So simplifying this becomes x squared plus 7x plus k to be equal to, when you simplify this, you have x plus a into x plus a, which gives you x squared plus 7x plus k to be equal to, you have x squared plus 2ax plus a squared. And by comparing the coefficients, the first term x squared, we said, is equals to x squared, and we have 7x being equal to 2ax, which when you solve for a by dividing both sides of the equation by 2x, you will have a to be equal to 7 over 2. So 7 over 2 is said to be a, where our k is said to be a squared. So k now is said to be 7 over 2 squared, which is equal to 49 over 4. So 49 over 4 is that term that must be added to x squared plus 7 to make it a perfect square. So we have x squared plus 7x plus k, which is now 49 over 4, to be a perfect square. Writing this in the perfect square format, we have x squared plus, factorize out 2, we have 2 into bracket 7 over 2x plus, write this in index form of this. You now have 7 over 2 all squared. So this, after being written this way, can be factorized to be x plus 7 over 2 all squared. So this is the method 2. We shall be using it in other examples. 15 says u squared minus 11u. So let that term be k, that when added factorizes it to be u squared plus u squared minus a. So it becomes u, not u squared, u minus a all squared. So you simplify, this becomes u squared minus 11u plus k to be equal to, I will just simplify this to be u squared minus 2au plus a squared. This becomes u squared minus 11u plus k is equal to u squared minus 2au plus a squared. Okay, comparing coefficients, u squared is equal to u squared minus 11u is equal to minus 2au. Solve for a by dividing both sides by minus 2u. You have our value for a to be equal to 11 over 2. And if that is that, it therefore means that 11 over 2 is that term that must be added to this to make it a perfect square. So this now becomes u squared minus 11u plus 11 over 2. Now let's factorize this. This becomes u squared minus 2 into 11 over, okay, we have not gotten our value for k. Our value for k is said to be a squared when you compare the last term. It therefore means that k is a squared, which is equals to 11 over 2 squared. And 11 over 2 squared is said to be 121 over 4. So 121 over 4 is that term that must be added here. So this becomes 11 over 2 u plus 11 over 2 squared. So that when you factorize this, you have bracket u minus 11 over 2 all squared. Question number 16. K squared plus 1 whole number 1 over 3k. I'm going to write this as an improper fraction. Simplifying it, we have k squared plus, this is 4 over 3k plus k. Okay, let me not use k again. Let's use another constant term. Let's call it b. To be equal to, since the coefficient of the first term is 1, we still have k plus b all squared. So simplifying this, you have k squared plus 4 over 3k plus b is equal to k squared plus kb 2kb plus b squared. So by comparing coefficients, okay, we shouldn't have used b here, but rather another constant term. So this should not be b. Let me use a. So plus a, and plus a squared. Okay, so by comparing coefficients, this is b. By comparing coefficients, the first term is said to be equal. Then you have it that 4 over 3k is equals to 2ka. Dividing both sides by the coefficient of a, you have it to be 2k. This will cancel out, and a is said to be 4 over 3k times 2 over 1, because we are dividing both sides by we're dividing both sides by 2. Okay, sorry, is times 1 over 2. So this is said to be 2 over 3. So our a is 2 over 3. But remember that b is that term. So b is equals to a squared. And b is said to be 2 over 3 squared, which is 4 over 9. So 4 over 9 is that term that must be added to this to make it a perfect square. So let's factorize it. This becomes k squared plus 4 over 3k plus 4 over 9. So simplifying this, we have k squared plus 2 into 2 over 3k plus 2 over 3 all squared. So this gives us k plus 2 over 3 all squared when factorized. Question 17. V squared minus 1 over 4v. So we said let that term that must be added to this be said to be k. And if k is that term that makes it a perfect square, it therefore means that its factor is going to be v minus a all squared, where a is a constant term. So simplifying this, we have v squared minus 1 over 4v plus k to be equal to, when you simplify this, it gives you v squared minus 2av plus a squared. And when you compare the coefficients, v squared is equal to v squared minus 1 over 4v is equal to the second term, which is minus 2av. I'm making a the subject of the formula by dividing both sides by minus 2v. You have this to be, minus will cancel itself, so you have v will also cancel out itself. You have 1 over 4 divided by 2, which is the same thing as you saying times 1 over 2 is equal to a. So our a is equal to 1 over 8. So what about our k? Our k is said to be equal to a squared. And if a is 1 over 8, so a squared becomes 1 over 8 all squared. That is, k is said to be 1 over 64. So 1 over 64 is that term that must be added to this to make it a perfect square. So let's factorize it. You have v squared minus 1 over 4v plus 1 over 64 to make it a perfect square. So let's simplify. You have v squared minus 2 into 1 divided by 8v plus 1 over 8 all squared. So when you have simplified it to this one, you can then factorize it as v minus 1 over 8 all squared. Kindly like our videos and also make your comments using the comment section, while you're also encouraged to share these videos with your friends. Question 18. Since the coefficient of the first term is not 1, so we said let that number be k, and if this is k, for us to factorize it, because the coefficient of the first term is not 1, it means that our value for t, our coefficient of t also will not be 1. So we are going to have a constant term, let's say at plus b all squared. That is what you get when you factorize it, because the coefficient of t is not 1. So you now expand this. This becomes 5t squared minus 2t plus k is equal to at plus b times at plus b. So this becomes 5t squared minus 2t plus k is equal to, when you multiply, you have a squared t squared plus 2abt plus b squared. So this now becomes, by comparing coefficients, we have it that the first term, which is 5t squared, will be equal to a squared t squared. Dividing both sides by t squared, you have it that a squared is equals to 5. You can call this equation 1 or whatever. From b, we have minus 2t. Comparing the second term, minus 2t is equal to plus 2abt. So I'll divide both sides by t, by 2t. Okay, so I have minus 1 to be equals to ab. I'll now square both sides. When you square both sides, the square of minus 1 is 1, and the square of ab will be a squared b squared. But I know that a squared is equals to 5, so I'll substitute a squared for 5, and this becomes 1 is equals to 5b squared, of which b squared now gives us 1 over 5. The last term is k, is said to be b squared. So b squared, k is equals to b squared, of which b is said to be 1 over 5. B squared is said to be 1 over 5 here. So k is also equal to what? 1 over 5. So 1 over 5 is said to be that term that must be added to 5t squared plus 2t to be equal to make it a perfect square. So this becomes 5t squared minus 2t plus 1 over 5. Now, writing this in the form of x squared minus 2xy plus y squared, we'll have to divide every term by 5 to make the coefficient of x squared to be 1. So this becomes t squared minus 2 over 5t plus 1 over 25. That I have done. So writing this in this form, it becomes t squared, factorize out to minus 2 into 1 over 5t plus 1 over 5 squared. And when that has been done, this is said to be equal to t minus 1 over 5 all squared. Now, I encourage you to follow it the way I have done it. Okay, it may look somehow cumbersome, but just follow the steps and you discover that it is made easy for you. Don't forget to like this video if you've not done that. Question 19, 4x squared minus 10x. Same thing as what we did. You say let that term be k, and if it is k, it can be factorized to be equal to, remember the coefficient of x squared is not 1, so it's going to be ax minus b all squared, minus because the second term is a negative. So we expand. This is going to give us 4x squared minus 10x plus k is equal to ax minus b into ax minus b. This becomes 4x squared minus 10x plus k being equals to a squared x squared minus 2abx plus b squared. And when you compare coefficients, you have 4x squared to be equal to a squared x squared. Dividing both sides by x squared, you have it that a squared is equals to 4 and a is equal to 2 because square root of 4 is plus or minus 2. So I'm going to take the absolute value of that. So second term, you have it to be minus 10x to be equal to minus 2abx. When you divide both sides by minus x, you get this. 2 can still go. 2 here is 1. 2 into 10 is 5, leaving us with 5 to be equals to ab. But we have it that a is said to be 2. So substituting 2 for a, we have 5 is equals to 2b. And that means b is said to be 5 over 2 when you divide both sides by 2. So if b is 5 over 2, b is 5 over 2, and we have it that k is equals to b squared, it therefore means that k is 5 over 2 all squared when you compare the third terms. So we have it that k is equals to 25 over 4. It therefore means that 25 over 4 is that term that must be added to 4x squared minus 10x to make it a perfect square. So if we have 4x squared minus 10x, you must add 25 over 4 for it to be a perfect square. And remember, the question says what must be added to 4x squared minus 10x to make it a perfect square. And thereafter, we should factorize it after making it a perfect square. And that's just what I did, or I have been doing in question 1 to 20. Okay, so I've made this, I've looked for the constant term that makes it a perfect square. Now what is left is for us to factorize it. So factorizing this, we will first of all express it in that form of x squared minus 2xy plus y squared. So the first thing to do is to divide each of the terms by 4. This becomes x squared minus, when you divide 10 by 4, it gives you 5 over 2 x. When you divide this by 4, it gives you 25 over 16. So this becomes x squared minus 2 into bracket 5 over 4. I have to factorize out 2 plus 5 over 4 all squared. I have to write this as a multiple of 5 over 4. So this, when factorized, gives us x minus 5 over 4 all squared. So that's our answer to question number 19. Let's look at the last question. Question 20 says 3x squared minus 10x. Also, the first term does not have a coefficient of 1. So we said let this be k, and that means the factor is going to be ax minus b all squared. So repeat what I have done. This becomes 3x squared minus 10x plus k to be equal to ax minus b times ax minus b. This is 3x squared minus 10x plus k to be equal to a squared x squared when you multiply ax by ax, then minus 2abx plus b squared. Now by comparing coefficients, we have the first term to be 3x squared is equals to a squared x squared. Dividing both sides by x squared, you have a squared to be equal to 3. Comparing the second terms, you have minus 10x to be equal to minus 2abx. And when you divide both sides by minus, this goes out. Divide both sides by x, this goes out. Divide both sides by 2, you have 5. So this becomes 5 is equal to AB. Now this is a squared. I don't want to deal with square roots, so I'm going to square this equation, and this becomes 25 to be equal to a squared b squared. Now substitute a squared for 3 in this equation. You have 25 is equal to 3b squared. And when you divide both sides by 3, you have your b squared to be equal to 25 over 3. Now, if b squared is 25 over 3 and k is equals to b squared, it therefore means that k is equals to 25 over 3. So 25 over 3 must be added to 3x squared minus 10x to make it a perfect square. And once that has been done, we need to therefore factorize. So expressing it in the form of x squared plus minus 2xy plus y squared gives us this. We first of all divide both sides by 3. This becomes x squared minus 10 over 3x plus 25 over 9 dividing by 3, and then factorizing out 2, you have x squared minus 2 into bracket 5 over 3 x plus 5 over 3 squared. Once the two terms in the bracket is wrong, it means your answer will definitely be wrong. So this becomes x minus 5 over 3 all squared. So that is your answer. As a recap, when you are asked to make a quadratic expression a perfect square, I told you that you will look for a term that when you add it to that expression, it makes it to conform with x squared plus or minus 2xy plus y squared. So any term that when added to this expression makes it a perfect square is said to be that term that is required. And once that is done, once you have expressed it in this form, you can then factorize it to be equal to x plus or minus y all squared. And I have been able to solve 20 good examples for you using two different methods that best factorize perfect squares. And that brings us to the end of today's class. Please kindly like our videos as you watch, while you use the comment section to interact with us. Let me know how many you got right and how many you failed. And if you think there's a mistake somewhere, you can also spot it out from mine. And if there's anything or any step I took that is not clear to you, you can also use the comment section to ask your questions, and I'll be glad to reply you. Thank you for being part of this class. See you in our next class. Bye.